Okay, this is sixth grade, and you can see I put on the marker board sixth grade 2E, 3A, B, C, and D. That's from the list of things that have to be learned for sixth grade. So you have this, or you should have it. So we're going to be working on the things that you'll follow up on Study Island under 2E, 3A, B, C, and D. Now, we're not going to discuss every bit of it in this video, but I'll break it up into two, possibly three. So let's start with the basics, which will be a discussion of fractions. Now, this should be something that you're already familiar with, so I'm going to write it large enough, fractions. So for us to really understand and work with fractions, we have to know the vocabulary. So everything in math has a vocabulary and it has rules. So we have to learn the rules, and the rules come from the vocabulary. So the first thing we have to understand is, what is a fraction? So a fraction, I'm going to say it a few times so you'll listen to it again. A fraction is a unit of measure. A unit of measure that is usually expressed like this. It's usually expressed as A over B, where A is referred to, which is on the top, A is referred to as the numerator, which you know, and the number on the bottom, you know, is the denominator. So you can stop the tape when you look at it and read these and write them into your notes. So a fraction is a unit of measure expressed as A over B, where A is considered to be the numerator and B is considered to be the denominator. And I'm going to put and right here, and the value, V-A-L-U-E, the value of a fraction, the value of a fraction is less than, that's not a good writing there. Again, I'm trying to make these markers dark so you can see less than 1. Now I'm going to repeat this so that you hear it more than once and you may be able to understand it. So a fraction is a unit of measure, generally expressed as A over B, where A is a number that we call the numerator, B is a number that we call the denominator. Denominator's on the bottom, numerator's on the top. And the value of this fraction is generally going to be less than 1, less than the number 1. So there's several different ways we could read this, which is what's the important part of this discussion right now. Because we can take that fraction and we can interpret it in different ways. We could say this is, for example, we could say this is A over B. We could say A divided by B, or so many parts of A compared to so many parts of B. So those are three different ways we could say this. I'm going to stop right here, clean up some board space, because I know this will be recorded and you can look at it and replay it. So let me say, before erasing this, we'll add a couple other aspects to it, because all this is the foundation work that you have to understand in order to work with fractions. So now what I want to say is, how could we read this? A over B. We could say A over B, if we were reading it in, we could say one way we could read that is A divided by B. That's one way. The order doesn't matter. So I can say A, and this line means divided by. That's what that says in English. Divided, D-I-V-I-D-E-D, by. This line says in words, A divided by B. I could also read this to say parts of A compared, C-O-M-P-A-R-E-D, to parts of B. So I could say A divided by B, parts of A, like 2 parts of A and 3 parts of B, or 6 parts of A and 8 parts of B, and so forth. So parts of A compared to parts of B. I could also say parts of the whole, and I'll explain this, W-H-O-L-E. Parts of the whole and the whole. I know that sounds confusing, but don't worry. So, parts of the whole and the whole. So the denominator, if we pretended for the moment that we had a pizza from Pizza Hut, and this was the pizza. So this is our pizza from Pizza Hut. And we have 8 people. So we would divide the pizza into 8 parts. So that's 1, 2, 3, 4. And we would keep dividing until we had 8 parts. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the whole is 8 parts. So if the denominator is the whole, it tells us how many parts there are in the whole thing. So let's say we have a contest, and the winner of the contest will get to pick a portion of the pizza for his or herself. So let's say, example, that you won the contest and you decided to get, because you were extra hungry, you decided to take 2 pieces. So we would express the amount of this pizza that you took by this fraction. 2 out of 8. Because there were 8 pieces in the whole thing, which is what the denominator tells us, and you took 2 pieces for yourself, which is what the numerator tells us, so you took 2 out of the entire 8. So the fraction that describes the amount of that pizza you took is 2 over 8, or you took 2 out of the 8, or you took 2 divided by 8. We could do all those things. We could do different operations, but so let's say you won the contest and you had the ability to select another student in the class that would also get to pick some pizza. And let's say they were hungrier than you, so they wanted 3 slices. So how would you describe that? You would say, well, I don't know why they tried to be greedy, but anyway, they took 3 pieces out of the 8. So you took 2. So let's say these are the 2 you took. And your classmate that you invited to participate took 3. And these are the 3 that that person took. So now the question becomes, how many pieces were taken out of the entire pizza between the 2 people? So you can see by looking at the picture that there were 5 pieces taken and 3 left. So if we wanted to do the math work, we could say, well, you took 2 8s, the other person took 3 8s, so when we add those together, we have 5 8s. Now, I'll summarize the rules later, but when you have fractions, you can add fractions if the denominators are the same, and we say the same means common. That's the word that we use in the vocabulary. So any 2 fractions that have a common denominator, you could add the numerators. So here, since it was 2 out of 8 was what you took, and your friend took 3 out of 8, that means together you took 5 out of 8. And that's what we will be doing with fractions. We will be adding, subtracting, multiplying, and dividing. But you can't add and subtract unless you have this thing here, common denominators. So even though we can see the picture and we know how many pieces are left, because we can just count the pieces left, we know there's 3. 1, 2, 3. But let's say we didn't have this diagram and we wanted to figure it out through mathematics. I would ask you, well, how many pieces were there in the pizza to begin with? There were 8 pieces. The denominator was 8, and all of the pieces were 8. So the fraction for the whole pizza is 8 over 8. 8 over 8 makes 1 whole pizza. So the entire pizza has 8 pieces out of 8 pieces. So if we wanted to say, well, how many did you eat plus your friend? We say, well, we ate 5 out of the 8. And my question is how many would be left? So that's a subtraction problem. So since my denominators are common, I can subtract this and say 8 take away 5 is 3. So there's 3 out of the 8 left. So I can see the picture that verifies that. And I also can use the math rules and operations of addition, subtraction in order to determine that. So now I'm going to take a moment, pause the tape, erase all of this, and continue with our operations, because that's what we will be doing. And we will also add to our definition of a fraction also. We did a pretty good beginning, but it's not complete. So I'm going to add, so this has been 15 minutes, so we'll stop.
Once upon a time, a turtle and a rabbit had an argument about who was faster. They decided to settle the argument with a race. The turtle and the rabbit both agreed on a route and started off the race. The rabbit shot ahead and ran briskly for some time. Then, seeing he was far ahead of the turtle, he thought he'd sit under a tree for some time and relax before continuing the race. He sat under the tree and soon fell asleep. The turtle, plodding on, overtook him and soon finished the race. Emerging as the undisputed champ, the rabbit woke up and realized that he'd lost the race. The moral of the story is that slow and steady wins the race. This is the version of the story that we've all grown up with. But our version of the story continues. The rabbit was disappointed at losing the race, and he did some thinking. He realized that he'd lost the race only because he had been overconfident, careless, and lax. If he had not taken things for granted, there's no way the turtle could have beaten him. So, he challenged the turtle to another race. The turtle agreed. This time, the rabbit went all out and ran without stopping from start to finish. He won by several miles. The moral of the story? Fast and consistent will always beat the slow and steady. It's good to be slow and steady, but it's better to be fast and reliable. But the story doesn't end here. The turtle did some thinking this time and realized that there's no way he can beat the rabbit in a race the way it was currently formatted. He thought for a while and then challenged the rabbit to another race, but on a slightly different route. The rabbit agreed. The turtle and rabbit started off. In keeping with his self-made commitment to be consistently fast, the rabbit took off and ran at top speed until he came to a broad river. The finishing line was a couple of kilometers on the other side of the river. The rabbit sat there, wondering what to do. In the meantime, the turtle trundled along, got into the river, swam to the opposite bank, continued walking, and finished the race. The moral of the story? First, identify your core competency, and then change the playing field to suit your core competency. The story still hasn't ended. The turtle and rabbit by this time had become pretty good friends, and they did some thinking together. Both realized that the last race could have been run much better. So, the turtle and rabbit decided to do the last race again, but to run as a team this time. They started off, and this time the rabbit carried the turtle till the riverbank. There, the turtle took over and swam across with the rabbit on his back. On the opposite bank, the rabbit again carried the turtle, and they reached the finishing line together. Both the turtle and rabbit felt a greater sense of satisfaction than they'd felt earlier. The moral of the story? It's good to be individually brilliant and to have strong core competencies. But unless you're able to work in a team and harness each other's core competencies, you'll always perform below par, because there will always be situations at which you'll do poorly and someone else does well. Teamwork is mainly about situational leadership, letting the person with the relevant core competency for a situation take leadership. And that is the end of the story.
Okay, you see I've cleaned off the board. Now we're going to continue this discussion of fractions. So I'm going to go back for 1 second and say a fraction is a unit of measure, which we've talked about, that's generally expressed as A over B. And it's generally going to be smaller than or less than the number 1. Now there's 3 types of fractions that we will discuss. One type of fraction we call a proper fraction. Proper fraction. This is easy, sounds difficult maybe. The second is an improper fraction. And the third is a mixed number. Now you'll be able to go back and copy this and stop the tape so that you get it down in your notebook. So we have to first understand what is a proper fraction. It's very, very simple, and as soon as I say it, you're going to know it. A proper fraction is a fraction, and I'm going to write it over here. Proper fraction, for example, A over B. A proper fraction is a fraction where A, which is the numerator, is smaller than the denominator. So you'll say A is smaller than B. Now you know A is the numerator, B is the denominator, so you could say it a little more sophisticated than what I said. You say a proper fraction is a fraction where the numerator is smaller than the denominator. So I'm going to abbreviate that for right now and say a proper fraction is a fraction where n, meaning numerator, is smaller than d, denominator. So wherever the numerator is smaller than the denominator, we say that is a proper fraction. So now, being smart like you are, you already know and can guess at what would be the definition of an improper fraction. If a proper fraction is one where the numerator is smaller than the denominator, an improper fraction is one where the denominator is smaller than the numerator. So, an improper fraction, A over B, where the numerator is larger than D, or D is smaller. We'll say where N is larger than D. Now we're going to show some examples of this too. Right now we're just using letters A and B, so it seems a little bit confusing perhaps. But the reason I'm doing that is to train your mind to think in terms of variables, because the farther you go in math, the more you discuss variables, and those are letters. So I'm trying to use this right now to start training you to think in terms of the letters. So the final type of fraction we have is a mixed number. A mixed number is just like its name applies. Mixed number. It's mixed between two things. And what are those things? is mixed between a whole number, and a fraction. Now, once you understand this, we're well on our way to doing all the fraction operations. So a mixed number is a whole number plus a fraction. So let me give an example of a fraction, and you tell me what it is. Or you say to yourself, you can't tell me because I couldn't hear you. But let's say we go back to the pizza. And how many pieces did you take? If you remember, you took 2 out of 8. Now, if I said, what kind of fraction is that? You will say, well, that's a proper fraction because the numerator is smaller than the denominator. So whenever I have a fraction and the numerator is smaller than the denominator, that is a proper fraction and it is less than 1. So we could say all proper fractions are less than 1, smaller than 1. What if I said you have a fraction and it's this fraction, 6 and 4? You say, well, that's not a proper fraction because the numerator is bigger than the denominator. In every proper fraction, the numerator is smaller. So this is just the opposite. So it's an improper fraction because the numerator is larger than the denominator. So this is a proper fraction. I'm going to put PF, proper fraction, and IF, improper fraction. So proper fraction, improper fraction. Now, a proper fraction is always less than 1. An improper fraction is always more than 1. And the fact that it's more than 1 is what creates the third type, mixed number. So let me explain what I mean. So we have this fraction, 6 over 4. You know it is an improper fraction. And I say you know because by now you realize that whenever the numerator is larger than the denominator, you have an improper fraction. So since I have 6, and I stretch your mind to think about this. Now 6 is the same as 4 plus 2. 6 is the same as 4 plus 2. So I've just grouped it to make 4 plus 2 for this example, divided by 4. That's what I have. Instead of 6, I have 4 plus 2. So I could go one step further and separate this denominator into 2 fractions because I know I could add fractions if I had a common denominator. So I can write this as 4 over 4 plus 2 over 4. Because you know I have a fraction, denominator is 4. If I can put 4 over 4 and 2 over 4, since my denominators are the same, I could add those and get 6 over 4, which is what I had to start with. You can see that right here. I think. So I'm positive, but I'm going to put a circle around it. So you can see that. I took 4 over 4 as one fraction by itself, plus 2 over 4 as another fraction, and you can see that if I add it, will be 6 over 4. So now what do I have now? 4 over 4 is the same as what whole number? It's the same as the whole number 1. Because any time I have the numerator and denominator are the same, that value is 1. So I have 1 and I have 2/4 left. So I have 1 and 2/4. So that gives me a mixed number is a whole number, 1 in this case, plus a fraction, 2/4. So 1 and 2/4 is the same as 6/4. It just looks different, but the value of it is the same. Now I'm going to show you how to work with this in different ways later too. So if we put this little asterisk here, we know we're going to come back to this eventually and talk about it some more. So you have these 3 types of fractions. So we have a proper fraction where the numerator is smaller than the denominator, and a proper fraction is, I'm going to add something here right now, is less than 1 in an inequality sign. An improper fraction is where the numerator is larger than the denominator, and that will always be greater than 1. So you see, now I'm adding in the inequality sign to the concept. And of course, a mixed number is always greater than 1 because it has a whole number in it. So anything that has a whole number in it, you know that is 1 at least, and the fraction will make it greater than 1. So actually, a mixed number is just another way to show how to express an improper fraction. So any mixed number I could change into a improper fraction, and any improper fraction I could change to a mixed number. So it's just convenience or the nature of the problem that I'm working with. So now I'm going to stop this tape. It's 11 minutes. I'm going to stop it, and we're going to go back to cleaning the board and also talk about the operations of addition, subtraction, multiplication, and division, which will all be simple enough to understand. So I'm going to pause this, clean off the board, and come right back.